slope notes. I want to make sure that we're very clear on our information. Okay, so the rate of change, how one variable changes in relation to another variable. Okay, and normally when we've talked about this, we have said, oh, wrong color, sorry. Let's get rid of it. Try that again. Change in y, and usually I write it as this, over change in x. And I write it like this. Okay, some examples that we've talked about is price. I did not mean to write it like that. I want to do this way, per pound. Or we could have done miles per hour. And remember, the reason I'm writing it like this is because the miles goes on top, per is the fraction bar, and then hour is on the bottom. So cost per month. And we'll do water used per minute. Okay. A lot of times when I write it for you guys, I say the change in y per, and then I say the change in x. Okay, over here. Now, there are two equations that we've talked about. We've talked about proportional. Proportional meaning that it goes through the point 0, 0. And that would be y equals mx. But really, the equation for all lines, sorry, I should say all linear equations, that would be y equals mx plus b. Where when we're talking about this, the m value is our slope. Slope is what we find. And then this value right here is our y-intercept. Okay, and y-intercept is where it hits on the y-axis. So anytime you hit on the y-axis, your value for x is always going to be that 0. Now I want you to remember that for when you're looking at the slope, it is always the coefficient of x as long as it's y equals. So if I had, trying to find a color that I can use, if I had y equals 1/2 x plus 6, okay, my slope for this would have been the 1/2. My y-intercept is the 6, and we would write it as 0, 6. Okay, the y-intercept is always the constant. Okay, so now a table. Now make sure that if it's going to be a linear equation, in order for it to be a linear equation, okay, It must have a constant rate of change. Has to have a constant rate of change. So when we're looking at this went up by 1. This went up by 1. This went up by 1. It doesn't always have to go up exactly the same on one side, but it does have to be constant in what it does go up or down by. So I will show you this. That went up by 2. It went up by 2. It went up by 2. So when I write the slope for this, or the constant rate of change for this, I write 1 over, and then I put 2. So the change in y, I should have written that, I apologize. It's the change in y over the change in x. We have the change in y over the change in x. Now, if we did it over here, remember my y's are down here. I subtracted 3. I subtracted 3. I subtracted 3. Right here, I added 4. I added 4. And I added 4. Now, I actually want to add something to this that's not on here. I want to put a new box over off to the side. And I want to add, let's say I did 27 here and I did negative 15 here. Now there's a rhyme and a reason as to why I did this. This went up by 8. And where's my green? This went down by 6. So I want you to look at this real quick. So if I was to write my slope, which means it's the change in y over the change in x. Now some of you may say, well, it doesn't work anymore. Well, boys and girls, if I have 4, and I should have done this in green, 4 over negative 3. And again, I should use my correct colors. But if I look at this one off to the end over here, I did 8 over negative 6. Well, if I simplified that fraction right there, if I simplified this, what would it simplify to? Well, 2 goes into both of those. That's a 4. And this is a negative 3. These two are exactly the same. Okay? The one thing that you do have to remember, super important, remember, y always is on top. Okay? So, let's look at if I have 2 points. So, I'm going to go with 0, 4 and 6, 12. So the slope is equal to, now I've been talking about the change in y over the change in x, but there's actually a formula. And that formula says, I like to write it like this. It says y2 minus y1 over x2 minus x1. These little numbers that we have here, oh, that was not good. Those just mean that they come from the same point. These two right here, these little ones, mean they come from the same point. That's all that those stand for. So, if I look at this, actually I went black. There we go. I'm going to subtract my y's. So I'm going to look at my y's. Does it matter which one comes first? It does not. 12 minus 4. Then on bottom, because I used 12 first, that means I need to use 6 first on the bottom. These two right here, they come from the same point. Then these two right here, they come from the same point. That's what's meant by this. So if I subtract those, I get 8 on top, I get 6 on bottom, and I get 4/3. Now, some of you may be saying, well, what if we wanted it to do the other way? That's fine. I could do it the other way also. And I'll let you know it's going to come out to the same answer. So instead of doing 12 first, if I did 4 first and 12 second, I just have to make sure that the 0 comes first and then the 6 goes second. If I do this, I get a negative 8 over a negative 6, which still simplifies to 4/3. It does not matter. It is exactly the same. I'm actually going to do this, and I'm going to do 2 different points. I'm going to do -2, 7, and I'm going to do 2, -1. Again, I set this up like this. And I'm going to subtract my y's. So 7 minus -1 on top. So I use 7 first. I'm going to use -2 first on bottom. Could I have done it the other way around? Sure could have. This on top would be get 8, on bottom -4. So I would have come out with -2 as my answer. Okay. If I had done it the other way around, if I had put the -1 first and the 7 second, and done the 2 first and the -2 here, still, again, same answer. -8 over +4 would still get me -2. So it doesn't matter which direction we do it. Okay, ratio. This is talking about the change in y over the change in x. Okay, so this is change in y over change in x. Another way to think of this, actually I want to do black, m equals rise, which means the vertical change, over the run, which is the horizontal change. Okay, and then we're going to come over here and talk about this. So if I'm talking about, this is where we get either our slope dude or our Mr. Almost said Mr. Potato Head. Mr. Slope. If it's this direction, it is increasing. If it's increasing, it has a positive slope. If it's going this direction, it is decreasing. That means it has a negative slope. If it goes this direction, that means this is a horizontal line and it has a 0 slope. And then this is vertical. and this has an undefined slope. Now, when it's talking about steepness, and it goes like this, this is not steep. Okay, if I go this, it's steeper. And then if I go, that was horrible. There we go. This is very steep. Okay, so that's the top part. Then if I come down here, the types of slope. Positive slope. Okay, if I have a positive slope, we are going to have a diagonal line. It is going to be going this direction. Equation examples. It will have both x and y in the equation. You could have y equals 2x. You could have y equals x minus 3. You could have y equals negative 1/2 x. Oh, no. Cannot be negative. Why did I put negative? There we go. 1/2 x. Y equals 4x plus 5. Anything like that. That would be a positive. Then if we have a negative, it again is going to be a diagonal line. But it's going to be going down like this. It also is going to have x and y in it. Has both of those. And this would have something like y equals negative x. Or we could have y equals negative 3x plus 2. Or we could have negative 1/3 x minus 7. Or we could have y equals 5 minus 2x. Okay. Then our next one is going to be a zero slope. This is a horizontal line. Okay. There we go. Horizontal line. Okay. The equations for this, it will only have a y. So this will be y equals 5. Y equals negative 3. Y equals 0.3. Y equals 1/2. Y equals 0. All points have the same y value. Okay, last group. Oh, what color haven't I done? Blue, this one. Now, we have an undefined slope. This is a vertical line. It is a vertical line, like so. This will be x only in the equation. So x equals 12, x equals 3.5, x equals negative 6, x equals negative 5/3, x equals 7. All points have the same x value. Okay. Now there are a couple of things that I want you to put on the back of this. Maybe. We're going to have to put it on another sheet. It's okay. I'll put it here. One of the things that we need to put on there, proportional relationships. They are linear and go through 0, 0. It's very important. We talked about that. Okay. The other thing that I want to make sure that I talk about back here is it linear? How can you tell if it's linear or not? So if I was to have this table right here, and let's say I picked, let's see, what numbers do I want to pick? I want to pick -5, -21. I want to pick 3, 11. I want to pick 6, 23. And I want to pick 1, 3. Now you may be saying, but they don't go in the right order. That's okay. They don't need to go in any type of order. All you have to do is look at this. So to go from -21 to get to +11, you went up 30. To go from 11 to 23, you went up 12. And here you go up 20. Then I look over here. Here I went up 8. Here I went up 3. Here I went, oh, wait a second. I messed up. Nobody caught me on it because I'm not on, you can't talk to me. This went down 20. And then this one went down 5. Now we have to look and see, is it linear? Well, slope says that I need my change in y over my change in x. And let's look at all of them. Let's look at my slopes. So if I look at my first set of slopes, I'm looking at 30, over 8. And if I simplify this fraction, let's see, 2 goes into both of it, so that will get me 15 over 4. If I look at this next set, then I have 12 over 3. And that simplifies down to 4. Because these two are not the same, this is not nonlinear. It doesn't make a line. Okay? Because the slopes are not the same. Remember we talked about if the slopes are the same, that means you have a line. So let's look at another example. Okay? If I have -3, -4, 4, 1, and I had -1, -3, 10, and 7, and I looked at this. Well, this went up 2, this went up 13, and this went up, no, it went down 3. Okay, and we'll do this side. This went, oh, Kim, you'd think you know math. This right here went down 2, not up 2. This over here went down 1. This one here went up 8. I think I put the wrong number in here. I think I was supposed to be, and this went, oops, again, it went down 3. Okay, so again, if I look at this, -2 over -1 will get me 2. 13 over 8, yeah, that. These two are not the same, so this is not linear. Okay, let me do a better job at this, because one of these was supposed to come out nice, but I didn't do it right. Let me give you some other ones, and we'll do another one. See if I can make sure that this comes out nice. -5, -13, 6, 9, 8, 13, and -2, -7. Now let's see if it'll work. This to this, 13 plus 9 would get me 22. From here to here is 4. From here to here is minus 13, 20. And then from here to here, I went up 11, up 2, down 8, 9, 10. So now let's look at the slopes. I have 22 over 11, which is 2. I have 4 over 2, which is 2. And I have -20 over -10, which is 2. Okay, so this is linear.